All right, guys, so we did multiplication. So now that means we're going to do division, which is section 3.5. And we're going to talk through some different models again of this mathematical operation. So let's talk about three models of division. Set of the partition model. The set of elements representing the dividend is partitioned into divisor number of subsets. Missing factor model, that's basically thinking about it as multiplication. A divided by B is the unique number C, provided that B times C equals A. Or repeated subtraction. Just like with multiplication, you can repeat addition. With division, you can repeat subtraction. So here's the set model, an illustration of that. With 18 cookies, you want to give them to 3 friends, and so you can show 18 divided by 3 equals 6 in this study. Or you could say 3 times what number of cookies equals 18. And so then they could think through the multiples, 3, 6, 9, 12, 15, 18. Okay, I need 6 to go in for C. For any whole numbers, A and B, with B not equal to 0, which is really important, because you cannot take anything and divide it into 0 groups. A divided by B equals C, if and only if C is unique. So we've had that for all the operations for addition, subtraction, multiplication, and division. The number A is the dividend, B is the divisor, and C is the quotient. So it's good for students to know those terms. This guy is the dividend. This is the divisor. Whatever the answer you get on top, that is called the quotient. This is explaining the repeated subtraction model. I take 18, I subtract 6, I get 12, I subtract 6 again, I get 6. So the last 6 cookies will fill another box, so 18 divided by 6 is 3. Given any whole numbers A and B with B not equal to 0, there's a unique number, we talked about that. And remainder, so this is if it does not divide equal. You have B plus times Q plus R. If 1, 2, 3 is divided by a number and the remainder is 13, what are the possible divisors? If 1, 2, 3 is divided by B, well, from the division algorithm, 123 equals B cubed plus 13. So from the definition of subtraction, I can rearrange this, right? And so if 123 equals B times something plus 13, because it says the remainder is 13, I can subtract 13, and then that means that B times Q must equal 110. And so now we're trying to figure out how can I get 110, right? So we're looking for two numbers whose product is 110, where one number is greater than 13. So far I have 1 times 110. It's even, so that can be 2 times 55. It's also ends in 0, which means 5 goes into it, so 5 22. And it ends in 0, which means 10 also goes into it. So 110, 55, and 22 are the only possible values of B because each is greater than 13. Let n be any non-zero whole number. N divided by 0 is undefined. Okay, so this is, I always wrote it like this when I taught high school math. N over 0. So if you have a number over 0, like 8 divided by 0 or 10 divided by 0, that is no. The answer does not exist. It is undefined. But 0 divided by a number, I would write it like this. I would say that is okay. 0 divided by a number is 0. Because if I have 0 things and I divide them by any number, every person gets 0. But 0 divided by 0 is also undefined because, again, you cannot have 0 on the bottom. So that one is also linear multiplication, division, and inverse operations. So just the idea that inverse operations are addition and subtraction, and also multiplication and division. If A and an interval natural numbers, then, okay, so this is more exponent rules. We talked about those with multiplication as well. I like to write it like this. And it is illustrated really well. If you have an example, like say I have x to the 5th over x cubed. This is like x. 5x is divided by three x's, and you can see that 3 will cancel, and you'll be left with x squared. The easy algorithm for that is taking the numerator and subtracting the denominator. Excellent. Here's illustrating this with these 10 blocks. You have 7 100 blocks, 2 10 blocks, which would be 20, and 6 unit blocks. So remember how many sets of 6 there are. There's one set of 6 flat with 1 flat, 2 logs, and 6 units left over. There are 2 sets of 6 longs and 6 units left over. So if you count those guys here, convert the 1 leftover flat to 10 logs. So that's why there's these extra now. So now you have the 12 logs. And so there are 2 sets of 6 logs and then the 6 units left over. And then that's a set of 6. So I have this set of 6, and then this set of 6, this set of 6, and that set of 6. So 100 sixes, 10 sixes, another 10 sixes, and 1 6. And then if you add that all together, you get 121 sixes. Again, to show this here, these are the 100s, right? So this is where you get the 1 100. Here you have the 2 10s, and here you have the 1 16, right? So tell me about 120. Base 5 again, this is the multiplication table. We talked about this before. So division is similar. So 43 base 5 and 3,241 base 5. So we said we're going to take 10 times 43, that gives us 430. And when you subtract, you get 2,311. 10 times 43 gives us 430 again. Subtract, you get 1,331. 10 times 43 again gives you 430, you get 401. And then if I take 2 times 43, I get 141. 2 times 3 is the 14, 11, sorry. And 2 times 42. 2 times 4 is 13. So that 13 and that 11, so do 130 and 11, that gives you that 141. And subtract, and then you can do that again, and you get 14 left. And so that's how we get 34. This is 110, 210, 310, so that's 30. And then you have 2 2s, so that puts you to 4. And then you have a remainder of 14. Breaking up the dividend. This is showing that you can break it up into parts. So I think if 56 is 5,600, and then you have the 48. So I know that 8 times 7 is 56. So 8 times 700 would be 5,600, and 8 times 6 is 48. So that's how I got the 706. This is just thinking about things that are divisible by that. So 105, you're like, oh, I know 105 is 90 and 15, and 90 and 15 are both divisible by 3. 3 goes into 90 30 times, and 3 goes into 15 5 times. And so it's rewriting the number into multiples of the number that you're dividing by. And that's another example of compatible numbers. So here we're like, okay, 3,752. I know 3,600. 6 times 6 is a perfect, 6 times 6 is 36. So 6 times 600 is 3,600. But then you'd have obviously more than, but this is just an estimation. Order of operations. When no parentheses are present, multiplication divisions are performed before additions and subtractions. Multiplication divisions are performed in the order they occur, and then additions and subtractions are performed in the order that they occur. So you might have heard MDOS. What am I intention? Hold on. So you might have heard this. Please exceed my nearest tally. This stands for parentheses and then exponent and then multiplication, division, addition, subtraction. Recently, my son learned GMA. This stands for groups. This is multiply slash divide, and this is addition slash subtraction. And really, if you only have multiplication and division, or you only have addition and subtraction, you can move from left to right if you wish, but because those operations are all commutative and associative, you don't have to move from left to right. So say I have 73 minus 2 plus, I don't know, 27. Can I move from left to right? Absolutely. You could say 73 minus 20 minus 2, 71 plus 27 gives your answer. Or you can say, you know what, I see 73 and 27, and I know that's 100. And so you can think about it as adding these two first, that's 100, minus 2, oh, the answer is 98. So you don't have to necessarily do it left to right. That's kind of the standard idea. Also, if you're multiplying and dividing several numbers, and you have something like, I don't know, this. Okay, yes, I could multiply 32 times 10 times 7 divided by 8 times 5 times 2. Making sure that you're multiplying all of these and then divided by the product of all of these. But you can also choose to divide first and then multiply, which is what I choose to do because if I'm trying to do this mentally and not with a calculator, I'm looking for like numbers or things that I can factor out. Is 32 divisible by 8? Yes. 32 divided by 8 is 4. So I already did this operation. 10 divided by 5 is 2, and 2 divided by 2 is 1. So really this whole thing simplifies times 4 times 1 times 7, and that is 28. And that is way quicker to do than 32 times 10 times 7 divided by 8 plus 5 times 2. And you're dividing by 8 and 5 and 2. So be careful with that. If you're entering that in the calculator, just a word of caution. If you do 32 times 2 times 10 times 7, and then you do divided by 8 times 5 times 2, that is not going to give you the right answer because you're actually dividing by 8 and dividing by 5 and dividing by 2. So just be careful with that. To put it in the calculator, you put 32 times 2 times 7 divided by 8 divided by 5 divided by 2. Or multiply these first and then divide by that product. If you have a graphing calculator, you can put it in with parentheses. But if you're using the standard calculator, you have to understand you're actually dividing by each of those terms in the bottom. So that's Little on division. As always, attempt your homework assignment, and please reach out with any questions you have.